Welcome back to Physics with Han. Today we're looking at polarization. You can see on this picture I've got a light beam. This light beam is composed of unpolarized light. And what this means is that we have vibrations in all directions. This unpolarized light is then passed through a polarizer or a Polaroid filter. You can see that the light waves passing out the other side only have vibrations in the vertical plane. So a polarizer limits the direction of the vibrations into one plane. Let's look at a combination of two polarizing filters. The first polarizing filter has a vertical transmission axis, and the second one has been rotated through 90 degrees, so now it has a horizontal transmission axis. So initially we have the light waves coming in and they are vibrating in all directions. Only vibrations in the vertical plane will be allowed to pass through that first polarizing filter. However, when those light waves which are vibrating in the vertical plane are incident on the second filter, which has been rotated horizontally, none of those waves are able to pass through because it only will let light pass through in the horizontal plane. Let's look at this graph below. This graph shows how light intensity varies as we rotate our second polarizing filter. We get fluctuations from a maximum to a minimum. Minimum at 90 degrees and 270 degrees, which is when no light is passed through, and maximum at the other points. Remember, there are two different types of waves. We can have longitudinal waves and we can also have transverse waves. Now, longitudinal waves have oscillations parallel to the direction of energy transfer or propagation. This actually means that they cannot be polarized. So that's really important to remember that only transverse waves can be polarized because their oscillations are at 90 degrees to the direction of energy transfer. In the real world, there are lots of examples of polarization. Here we've got some sunglasses. Now, sunglasses contain polarizing filters, and filters have a vertical transmission axis. So they will only let light with oscillations in the vertical plane pass through, and none of the other planes of light will be able to pass into your eye. So this helps reduce glare, and glare is actually caused by the reflection of light off horizontal surfaces, such as a wet road, the surface of the water, or maybe a skiing slope. So in these situations, using sunglasses is really important to protect your eyesight. Most of the light that you see is unpolarized. This means the vibrations are in all possible directions. But light reflected off some surfaces is partially polarized, so some of it is made to vibrate in the same direction. However, we can still polarize this light further so that all of the light is just in one plane, and this will limit the glare from the reflection. And in photography, we can do this to reduce this shininess. TV signals are polarized by the orientation of the rods on the transmitting aerial. So in order to receive a strong signal, you have to line up the rods on the receiving aerial, maybe attached to your house, with the rods on the transmitting aerial. If they're not aligned, the signal strength will be lower. So the rods on TV aerials are all horizontal in order to get the best possible signal. Let's have a look at an exam question on polarization. Okay, starting with the first part of this question, which is worth 2 marks. State 2 properties which distinguish electromagnetic waves from other transverse waves. So we have to think about 2 things which is unique for electromagnetic waves and that other transverse waves do not exhibit. So other transverse waves could include water waves, or maybe waves on a rope that you could create. Let's have a look at what we could put then. So we need 2 points. For the first point, we could say that all electromagnetic waves travel at the speed of light. So this is 3 times 10 to the 8 meters per second. So all of the waves in the electromagnetic spectrum will travel at this speed. The second thing we could say is that all electromagnetic waves will be able to travel through a vacuum. So remember, a vacuum is where there are no particles present. So electromagnetic waves actually just consist of electric fields and magnetic fields, which oscillate at 90 degrees to each other. Okay, moving on to the second part of this question. Describe what is meant by a plane polarized wave. I would recommend learning this because if it comes up, it's a really good idea to just know the answer and write it down. It'll save you a lot of time. So this is when oscillations of particles, or you could say fields, because obviously it depends what type of wave we're talking about. Particles could be for a water wave, fields could be for an electromagnetic wave. So it's oscillations of particles or fields along a wave which are in one direction only. That's really important. Now this is 2 marks, so that first point would get you 1 mark. The second thing we could say is that these vibrations are perpendicular, which means at 90 degrees, to the direction of wave propagation, or you could say energy transfer. Moving on to the last part of this question then, we've got 2 polarizers. The first one has a vertical transmission axis and the second one has a horizontal transmission axis. And we're asked to explain why the lamp cannot be seen by the eye. Okay, so we need to describe what's happening. This is actually a 2-mark question. So again, we really need to be looking for 2 points to make here. So the first thing we could say is that light passing through the first polarizer will only have vibrations in the vertical plane. So that means that the light has been vertically polarized. So all of the light leaving polarizer 1 is vertically polarized. It only has vibrations in the vertical plane. This light is then incident on the second polarizer. Okay. However, only light which is horizontally polarized can pass through this second polarizer. And because none of the light incident on this second polarizer is vibrating in the horizontal plane, no light will be able to pass through this polarizer and no light will enter your eye.